Often when people are first learning about predicted probabilities, probability theory, political science, quantitative research analysis, it can be a bit abstract. And so in this video, I wanted to touch on two examples of how people can use some basic statistics like mean, standard deviation, confidence intervals to try to understand the world around us and issues that we care about that are topical or that are long-standing challenges to trying to understand or conduct politics or international relations. So in this video, I want to talk about two brief examples. The first one is public opinion polling, how we can understand what the results of polls actually mean and what we mean by margin of error when we're looking at polls. The second example is how we can detect electoral fraud, even though it's something that people want to hide, using the basic data that are generated during the election process in a lot of countries around the world. The first example is the voice referendum. Simon Jackman at the University of Sydney has this great GitHub website where he posts information and aggregates polls from different sources to try to understand the trajectory of polling over time, as well as to get information from previous polls and pool it with the newer polls to try to understand how confident we are likely to be as to how the larger population feels about a particular issue or the likelihood of voting for or against a specific issue. In this case, the voice referendum here in Australia, due for a vote in October 14th, 2023. And you can see here that there's been a number of different polls in those circles, and the average is that solid, thick black line. And you can see a pretty consistent decline in recent months. You do have outlier polls that are either below or above the confidence interval around the mean value. In the previous video, I talked about how confidence intervals are calculated. You could look at that if you need a refresher for how confidence intervals are calculated. In this case, how confident we are at a 95% level. Are we 95% confident if we go and get samples from the population about their beliefs or their support for the referendum 100 times, 95% of the time, the population mean the true opinion that people have about, in this case, the referendum, is going to lie within that upper and lower bound in yellow. And so you can look at each one of these polls individually. I did here using this essential research poll example. There's other polling agencies that do polling that Simon collects. However, this one is particularly transparent in their methodology, and it's also an outlier in a way which we're going to talk about in a second. But you can see and go to their website and look at how the poll breaks down supporting the voice or not by a whole bunch of different factors, including gender, age, voting intention, as well as where people live within the country. And what you can see is that red line, the no vote, passed over the yes line in August, and it stayed above there since. And there's a bunch of other information available on their website as well. In my class, students have talked about where the importance of information as a goal for learning about social science research, to become a better consumer of data, as well as some want to be a potential consumer of academic research or even possibly a producer of that research. And so what's interesting, a lot of my students now are becoming increasingly interested in understanding misinformation or where people get their information and how that might shape people's beliefs about what's going on in the world. And so I thought this was interesting. In this poll, they also show the answers to a question about where people got their information, in this case about the referendum. And you see, in this case, as with a lot of other political issues, a lot of the information comes from friends and family, more likely to come from friends and family than the workplace or social media or other outcomes. If you go to their website, I'm always a fan of looking at the methodology for different measures. Previous weeks, we've talked and looked at the Transparency International's measure of corruption, their methodology for trying to aggregate different sources to get information about underlying corruption. Here, you can go to the methodological disclosure statement, and you see that they weight their sample to try to match the population according to a couple of different characteristics: age, gender, location, and party identification. But what is more interesting here in trying to calculate what the confidence intervals are around that one specific yes and no vote that we just looked at, 48% no, I think, and 42% yes, is by looking at the margin of error. So here, the most recent ones I was able to get for this particular study was 3.1. Seems like they try to aim for a margin of error of 3.1. You can use that to try to calculate confidence intervals to see whether that there's a chance that the population mean for the yes and the no potentially overlap. So how can we generate knowledge of probability to understand polling results? You can convert those polling results into measures of confidence that the population mean, the underlying support or opposition, in this case to the referendum, is within a certain range around that sample mean. The margin of error is half the width of the confidence interval, so you don't have to use any of the complicated equations. They're not really that complicated, but the standard deviation and the standard error of the mean equations in the previous video. With this, all you have to do is double the margin of error to get the overall size of the confidence interval that's centered on the mean. Basically, the margin of error is half the width of the confidence interval, which means confidence interval is twice the margin of error, plus and minus around the average value. So if you take this poll from Essential Research, you have a number of people surveyed was 1,151 with a yes percentage of 42 and a no of 48. You can calculate those confidence intervals around those different values. And I chose this one particularly because those lower bounds with a 95% confidence slightly overlap between no and yes, which is in part attributable to why it's slightly above those confidence intervals Simon had using all the different polls together. But often this is just one metric by which you try to infer what we have knowledge from our samples to the underlying population that it is meant to represent. Here you have a slight overlap, but with all the other different studies, it seems like there is a statistically significant difference between the results for the no and the yes in this example. If you want to know more about the specific referendum that we're holding, there's already been published academic research like this one by Murray Groot in the Journal of Australian Studies, and I'm sure there'll be other ones forthcoming. I wanted to turn now to the second example of the use of probability to understand political phenomena that I really find interesting or topical. This one is related to election fraud because it is something that people talk about and decry, that you want to have free and fair elections around the world. One of the difficulties that people have who monitor elections or trying to evaluate how well run the elections are in their particular country, whether there is a potential for bias towards a particular candidate, it can be hard to do. So even in Australia, we're very transparent with the Australian Election Commission, looking at different polling results. And I don't know if you have. I would encourage you, wherever you are, to look at the polling results to see in your district where you voted or others around. This is a random one from Eastern Adelaide, Christian Brothers College On Wakefield Street, you can see the results for the different candidates from the latest 2022 May election. You had the Liberal Party candidate getting 311 votes, the Australian Labor Party candidate getting 359 votes, and so forth and so on. What is important when actually looking at these, and what some creative minds did when looking at the polling results, is saying, okay, there are 10 possible last digits in each one of these different numbers for the number of votes. So if the vote counts are truly random and you have an equal probability, kind of like a die, of getting a 0, 1, or 2 on up to 9 as the last digit in a particular voting result for a particular candidate, then if you aggregate across all the number of different sources, you should have a roughly flat distribution if it is a fair election across all the different polling stations. That it should be roughly flat, and if it's not, then you have the potential for bias. And this paper by Berber and Sacco in political analysis, Walter Meeban has done some other work on this. They look at a couple of different elections results, the last digits from all those different candidates, like with the Adelaide example. And you see here the graph in Senegal, the 2000 election. You have all those different digits for a particular candidate, as well as those in the other columns, and you can see the mean expected value should be at 0.1, because all of those probabilities together for those 10 different options by necessity have to equal 1 due to probability theory. And then you have the confidence interval around that, ranging at the lower line at 0.09 up to 0.11. So you have a mean that's slightly off that 0.1 because of observational data. And then you contrast that with a Nigerian election in 2003, and you see those columns for the zeros are overrepresented and above that threshold of the upper bound of the confidence interval. And they conclude that because humans are bad at truly understanding randomness, or lazy, or they just have a tendency towards round numbers, that when people are, if you are making up the results in your particular polling station, you might be more likely to just put a 0 if you think you're not going to get caught and you just want to move things along. You can use zeros. You can see 2s are actually underrepresented for the number of registered voters and total votes. And you can also see this just within one country over time. The paper talks about how there were more allegations of fraud and a less free and fair election in 2007 as opposed to 2000 Senegal. And you can see that also with the 0 digits being overrepresented here, which I think is, for me, a kind of simple but interesting example for how we can take probabilities that should be completely flat and be able to apply it to understand something as basic as the last digit of polling results for particular candidates or political parties, to potentially tell us something is anomalous or not what we would expect. That would enable us to think theoretically about what places might report those zeros, what changes between the different elections, or other theoretical issues about the electoral process in those countries. So these are just two quick examples of how we can use the basics of probability and the different outcomes that we have in front of us to be able to understand the underlying distribution of beliefs in the first example about support or opposition towards a referendum, and in the second case towards potential for otherwise hard to observed electoral fraud. And with that, thank you for your time. Hopefully this has provided a useful foundation for the next weeks as you move forward in your path and understanding the kind of statistics and methods that we use in comparative analysis in social science. With that, thank you, and I hope you have a great week.